So, Somali, thank you, and thanks for the invite. You and I have been following these similar paths of starting in genomics and then realizing genetic data by itself is important, but much more important when we connect it to all the other dimensions and the previous talk about the cube of all the different data types and how do we connect this data and make a difference in it. And what I want to talk to you about over the next few minutes is the vision of a data biosphere, what problem we think this vision can solve. I think it's a problem that will resonate with everyone in this room just from the conversations this morning. What our vision is for a data biosphere and how we see it getting started to be built right now. And I'll use the All of Us research program as an example, just a taste of how to put this in practice. So the first question is, why would we build a data biosphere? What problem would it solve? The Global Alliance for Genomics and Health has been working for the last 5 years to avoid this slide, to have this not be the world that we live in, because this is the default world. The default world is there will be lots of separate small n experiments that will all be good experiments, that will all generate data for their domain, and then every researcher, every program, every lab will build their own tools to work with the data from their experiment, and hopefully somehow we'll talk to each other enough to get some knowledge out of all of that to make a difference in the world. We can do better than this default. We've already heard people talking about ways to do better. This is part of the motivation. At the Global Alliance for Genomics and Health meeting in Orlando last October, they asked a few of us to put a 140-character message of why data sharing was important, and I was the tech guy in the room, so I did equations. But what this says is really the premise that a lot of people here have been saying. What we want is not lots of data, we want actual big data. We want to actually build the tools and systems and processes so that we can assemble the data from all the separate measurements and experiments and all of that. And instead of having siloed data and siloed tools, let's see if we can pull this all together, get to the point where right in the middle, the notion of extremely large databases are actually useful, right? How can we actually live in a world where we have enough unification and harmonization so that we can apply the tech expertise, bring it with the life science expertise, and then use that to make a difference in the world. So that's the big picture idealism saying we can do better, why we should be able to do something. We also had a very pragmatic reason. So I'm going to tell you about 3 projects that a few overlapping groups of people from different institutions have been working on over the last few years, and the problem that each of these projects needed to have solved. So the Human Cell Atlas, which is funded by Chan Zuckerberg right in the Bay Area here, that at a very high level, the notion of what they're trying to do is get a bunch of people to generate a bunch of useful data and upload it to a cloud-based data store, build various storage and ingest and analysis tools to pre-process that data, and then take that data and make it available to a community of researchers with some sort of collaborative work environment in which the researchers could do work and some sort of tools library to share. So this is a very high-level sketch of what the Human Cell Atlas wanted to build from a data infrastructure point of view with a set of collaborators working to build it. Here's another project, completely different project. Doesn't have anything in common, except for the answer. Doesn't have anything in common with the Human Cell Atlas. The National Cancer Institute has funded these cloud resources to take the data that started with the TCGA data, generalize it into a genomic data commons, and build a stack that lets you upload it into the cloud, organize it, store it, provide tools to do some pre-analysis, and then make it available with collaborative workspaces with shared tools. Interesting. Then we had another project, the All of Us research program, which needs exactly the same sorts of things. If you were paying attention to the names in the bottom right, there's a lot of overlapping institutions building these things. So from a purely pragmatic point of view, we're all constructively lazy whenever we can be. Let's not invent the wheel over and over again if we can find a way to build systems that will solve multiple problems once. So it's nice when idealism and pragmatism point in the same direction. That means you don't have an ethical question, you just get to work and start building things. So given all that, we said we see an opportunity, and the we here are all the different people who have been working on all these different projects and these different combinations. And a few of us said, let's articulate this, let's put the story out there, let's start this as a community conversation. And we published a blog post back in October. It's at databiosphere.org. The next few slides, I'm just going to give you the Cliff's Notes version. I wonder what Cliff's Notes is these days. Anyone have enough undergraduate connection to know what the... Khan Academy, yeah, that's certainly part of it. But here's the Cliff's Notes version of the Data Biosphere blog post. You can see the institutions represented there at the bottom. And what we did in the blog post is we laid out first some principles for how this should be built. Then we talked about what should be built. And then we talked about how should it actually be deployed and run. So the principles are all things that I think a lot of people here will just nod to, that you've all been part of and seen the benefits of this. But the reasoning behind these principles of modularity and community and standards and open, the reason is if you actually want an ecosystem, if you actually want a biosphere that everyone can play in, walled gardens don't work. You're not going to get everyone. There are always reasons why people are going to like some of what you are using, but not all of it for their environment for whatever reason. So it's important that this be built in a way that both technically and sociologically is open to being mix and matchable, is open to people reusing everything that makes sense to reuse and then extending or adapting however that makes sense, and then ideally having those extensions be available to others. So these principles we think are important if we actually want to live in the world we talked about, where all of where we avoid the silos of data and avoid the silos of tools and the silos of researchers. All right, so given that, what should we build? Well, this is the schematic of the convergent evolution that we talked about before. These were the building blocks that we saw multiple projects inventing over and over again and saying, okay, we can actually use this to define some clean interfaces between pieces and say, you know, I might not like your analytical engine for my data, but I should be able to swap in my analytical engine and have that just work. Or, you know, I have a library of tools here that's maintained in a certain way, and you might have another library that's maintained in a different way. Great, let's let people tap into both libraries, and so on. So the intent is to say these are the major building blocks. Let's see, as we build out the individual projects, if we are all thinking about it the same way, can we start to put these nice boundaries around, follow the good fences, make good neighbors principle of software development, and say, can we actually define interfaces between these pieces in a way where they'll plug together and start to have something. And so these were the major pieces that we said we think this is at least a starting point for an extensible, shareable architecture as we do this. All right, so that's great. You know, we have some nice principles, we have some nice code. The thing that's missing is DevOps. The thing that's missing is biologists, scientists, clinicians. Show them a GitHub repository and they'll say, huh, now what, right? This is not actually speaking the language of the people that we want to empower. So what we also need is a model for how will this modular code be deployed. And the model that we think is what's going to happen naturally is there will be multiple data environments that will be built by different people for different purposes. Some people will choose to say, I'm going to assemble the components of the data biosphere that I choose for my project into a data environment that's going to run on infrastructure I control and make it available to my researchers. Great. We just save them a lot of time building things, and the practices and tools they develop will be shareable with other people because the components are swappable. Other people may say, hey, I want to build a multi-tenant data environment that is able to pull in data sets from lots of different places and make it available to a lot of folks, maybe make it very easy for someone to drop their data in, maybe make it very easy for people who have permission to do cross-analysis across all that. Great. So we think there will be more than one data environment. Some people will have constraints around physically or geographically where it runs. That's all good. Same colored boxes across the environments means we get a lot of the benefits of the data biosphere. So that's the vision that we laid out, and we very much saw it as a call to arms, as a directional thing, as a vision that needs to be made real. That was back in October, and we said, let's get started. We had some immediate projects other people do. Let's get started with the community, start putting these ideas out there, and start building the vision that we articulated. All right, so that was 6 months ago, conceived 6 months ago. Not yet born, but it does have a heartbeat. So this is a GitHub repo where a lot of these components are starting to be built. A few dozen repositories, several dozen people who are starting to contribute. If you're interested in checking out the code, feel free, but low expectations, please. This is still early days. We chose right from the start to say if we're going to adhere in and believe in the principles of open and community, we should start in the open. We intend to make more noise about individual repositories when we think they'll productively accept new. It'll be a good use of people's time to take a look at them, but you're welcome to look at any of this early. Quick tour of a few of the components that are being built. There's a need that many projects have for data browsing using faceted search, and there are a couple of different repositories that are building out 2 different versions of that module for exploration of data sets, and then and exploring immediately takes you to, as Nigam showed in his talk, to the problem of, hey, I want to build a subcohort. That's often the important place to start. So a couple of different projects working on that. There's a Leonardo project, which is a wrapper over Jupyter notebooks to make them really easy to manage and deploy in cloud environments. Just avoid all the plumbing and yet enforce security boundaries and permission boundaries around access. So so just remove friction from using Jupyter notebooks in this context. Cromwell and Toil are 2 examples of services to run batch workflows. There's a few of these out there. These are a couple of the ones that are standard ways to say, I have defined a pipeline. Here's a way I can package up my pipeline and just give it to one of these services to run. As long as there's a standard interface to say, how do I run a pipeline, then there can be multiple execution services, which these are. The Job Manager is a UI service that provides a nice visual way if you've just kicked off 500 workflows and tomorrow you're going to kick off 2,000 more workflows. Just keeping track of how they're all doing. It gets a little bit beyond what you can do by having 500 tabs open or by doing PS a lot to see which of your jobs are doing what. That just stops scaling when you get to hundreds or thousands. So we built a UI that talks to the actual execution services, just makes it run together. Lots of these little building blocks are starting to come together. All right, so that's the problem we want to solve. Those are a sketch of how we see it being built and early progress. I'll give you a very quick tour of the All of Us research program, which was mentioned earlier, and just show you how, not in detail, but how do these components in this vision, how do we see this being exposed to the All of Us research community? So in one slide, what is the All of Us research program? Well, as was mentioned earlier, it's an NIH project to enroll 1 million or more US participants in research and gather longitudinal rich data on them, which will include biosamples so that we can run genomic and other assays. It will include surveys so we can get lifestyle information, and it will include clinical information so that so we're getting permission to access their EHR data, which means we're signing up for all the data cleaning that Somali and Nigam and others talked about, that we know that this is a large effort. The All of Us research program also very much wants to have this data be as widely available as is possible, consistent with the consents and desires of the participants. So we're looking to build a platform that is scalable to all researchers everywhere, and including and building on a lot of the components we just talked about. From a timeline point of view, all of us started enrolling alpha participants to shake out the whole enrollment process about a year ago. The national launch, which will open it up to all Americans, is later this spring. And then that means we're aiming for a researcher launch about a year afterwards, after the participant launch. And that's when the first tranche, because this is ongoing growing data, but the first tranche of this data will be made available. The philosophy of the researcher model here, which is one that I think is familiar to a lot of folks here, is really embracing the shift from the traditional model of if researchers want access to data, they get permission and then they download a copy of some or all of the data to their local environment, and really shifting to a model of let's bring the researchers to the data. We think that this model is both practically necessary just because of scale, just add up the cost of storing a petabyte at each research institution versus storing a petabyte once, and that becomes obvious. It's also more secure because you have a central place, and we're no longer as weak as the weakest infrastructure that has permission to access it. We now have central. Technology never guarantees security, but at least you can do better when you have one place to do it. And then what I think is the most important advantage of bringing researchers to the data is that it encourages collaboration instead of siloing. Doesn't force it. If you and I choose not to work together, that's fine. But it would be nice if we decided to collaborate, if the moment you said, yes, you may, I could. Right? We want to shrink that gap, and by having the data and the tools in one place, it makes it much more possible. It nudges towards collaboration instead of nudging towards siloing. All right, so that's the intent of how we're building up the data and research platform for all of us, all being built on and using the Biosphere vision and components that we talked about. A few just early wireframes of, so what will the flow look like? What is the top layer, those individual project-specific portals? What do we think that will look like for all of us? There will be a sign-up flow where a researcher can go, create an account, verify who they are, and go through the appropriate approval process, which we hope will be very lightweight. That's being worked on with the appropriate committees to figure out the details of that. But the goal is to allow researchers to be a very broad definition of researcher, everything from citizen scientists to high school students to PhD researchers at academic medical centers. So the intent is to have a way for all of those people to participate, which means you need some sort of friendly online way to get started. There will be tools to do quick and easy click and browse kind of selection. This is just an indication of the intent to provide fairly simple ways to navigate and browse through the data, akin to some of the things that Manny showed us earlier for quick ways for people who don't want to write hairy queries to be able to get a sense of what's out there. And then there will be a way to create a workspace where you actually decide who do you want to share your work with, and then make that work, and then do your work. And if the fine print here, it says, hey, here are the cohorts I'm working with. Here are some of the notebooks that I may have created to do analysis over my cohorts in my space. Those notebooks would be shareable. The whole workspace would be shareable. If you want to run some pipelines, that fits in too. So that's the model of how we think that the vision of let's make all the data useful to actually get the insights and make a difference, we're right on the edge of that world coming into being. And I think a lot of the people here are working to make that possible. And it's an exciting time to be in this space. All right, thank you. I think we have a minute or two for questions. Sure.
So in the citizen science arena, like, what are you thinking of in terms of how is that going to be enabled? Because, what's stopping the citizen scientists from making mistakes or doing something that's unethical in this ecosystem?
Great question. And it will be a combination of things, and the details are being worked out. One is tiers of data access, where there will be some data that is less risky than other data, and the bar for getting access will be lower. So that's a big part of it. One is anyone who wants access is going to sign a data use agreement that spells out very clearly what the expectations are. And the more potential risk any particular data set has, the more strict the terms of the data use agreement will be. And then another is that you agree, as when you're accessing the data, to be subject to auditing of your use. So you say it's okay if the program looks over your shoulder to make sure you're adhering to the data use agreement that you've set. I can't say we, I don't expect that will be a very heavily used capability, but the ability to audit is important because it's just one more check and balance on the whole defense in depth.
So just a quick question, the tools that are being built, are they new tools or are they wrappers around existing tools to match them to the interfaces that you've defined? And if they're new tools, why did you decide you have to go out and build new ones?
Yeah, the question was, when are we using new tools? When are we wrapping existing tools? I'd say some of both. Most questions can map to an XKCD comic. This is the one about, we believe in standards, so much, right? So it's like problem. There are 14 standards. Solution, let's convene a committee to solve this. Result, there are 15 standards, right? You've all seen this. But it's a balance, right? The reason that meme exists is because sometimes that is the right answer and sometimes not. So, for example, for interactive analysis, we love Jupyter Notebooks. Everyone loves Jupyter Notebooks. We think that there are things you can do to wrap Jupyter Notebooks and make them easier to use. We think there are libraries you can plug into Jupyter Notebooks that will connect them better to the environment in which they're running. So, for example, if I've defined a cohort using a visual tool, I want to be able to launch a notebook and then just refer to that cohort with a line without having to figure out how to plumb it together. But I don't want to reinvent Jupyter Notebooks, for example. Around running pipelines, I'd say this is one where every engineer I've talked to knows they can build a better pipeline running system. Everyone, including the ones who've worked for me. It's like, this is it. This is moths and flame. I don't know a cure to this, but I do know that there's been some convergence around the workflow definition language, which is huge, because it means that now it can just be a practical question of, I don't care which way you run this thing, as long as it runs, and then it'll sort out over time. So as long as we can plug something in that plays the standard way, people will pick the ones that work for their environment, and so on. But practical choices case by case.
Hey, I'm wondering if you can describe data lineage and how you're going to track it through the system as results get built on other results, that sort of thing.
Yeah, data lineage and provenance is, we don't have magic, we don't have any silver bullets there, right? We have a couple of thoughts that we think, well, two layers. First, there's data lineage for the data that the data generator creates, and then there's what researchers do on top of that, right? And I think those really need to be looked at differently for the sociological reasons of just what tools can you use to say thou shalt versus please. Best practices for generating data, of course, are to be very clear, reproducible, have good provenance, and for the All of Us research program, I think the one moderately interesting thing we're doing there, not deeply interesting, but practically interesting, is we've created the notion of a raw data repository and a curated data repository, have shared that notion have educated all the people in the program about that, so they're thinking about it, have said that the job one is just assemble all of the data coming from all the sources into a raw data repository, and it's an append-only repository, right? Its job is just keep stuff and don't lose it. Right? Just keep it, know where it came from, and don't mess with it. It's like, if on July 7th someone wrote this fact, well, that is always true that that's what they said on July 7th. So that's a raw data repository. Then there's a curation process to generate a curated data repository, which is meant to be the analysis ready. And that happens repeatedly. And in each one is a snapshot. So there will be the fall release of a curated data repository for all of us, and it is what it is, and it's not going to change. Then there will be a spring release that will have both, all dimensions of the cube will get bigger. There will be more data over more participants, more data types over more time, and there will probably be some better curation. We might say, hey, we found a better way to harmonize these lab tests from here and here. But each release of a curated data repository will exist as a snapshot, and then researchers will point at the latest release by default, but they'll always know and can say, I know which truth that came from, and in creating it, we'll know how it was curated from the raw data, so that's that bit. What researchers do is what they want. I think the notion of having standardized tools to run batch pipelines and standardized tools to manage your notebooks makes it a lot easier to do good lineage and provenance if you want. If you don't want, I can't help. Okay, I think we're at time. Thank you.
Thank you.